The equality of mixed partial second derivatives is used often in thermodynamics. For example, thermodynamics tells us that the entropy and the pressure of a substance can be expressed as partial derivatives of a function called the Helmholtz free energy represented by A. A is a function of V and T, which is a function of V is for volume, T is for temperature. In terms of the Helmholtz free energy, A, the entropy is written as this, the pressure is written as this. So let us calculate this. Stop sharing. Start video. Start video. Stop sharing. A is the Helmholtz free energy. This A is a function of volume and temperature. A is a function of volume and temperature. In terms of A, the entropy is written as, entropy S is written as the partial derivative of A with respect to temperature at constant volume. And pressure minus the partial derivative of the Helmholtz free energy with respect to volume calculated at constant temperature. Anisnebako. Aduga, physics in physics, most of the functions in most of the cases continuous whatever. In most of the cases, the functions are continuous. These partial derivatives, and again, magi amuk partial derivatives. So, in most of the physical cases, these are continuous functions. Aduna I am the money of commerce. Aduna mana bagi example to lower cell. Money harigadi. Let us take CGC first with respect to T nidra. Now let us differentiate this with respect to V volume. So del 2A by del V del T. First you differentiate with respect to T, then you differentiate with respect to V. So this is equal to first you differentiate with respect to T, del A by del T at constant volume. You'll get some function pressure minus the pressure, and this will again depend upon temperature and volume. This will again depend upon temperature and volume. So let us differentiate this again with respect to volume. Volume differentiate and keep the temperature constant. Second order partial derivative mixed partial second derivatives to manai harabanina manabagi example see, first you differentiate with respect to volume at constant temperature, then you differentiate with respect to temperature at constant volume. Uneasy manner. Uneasy money have. Uneasy money have it. This is equal to T no halazu, V no halazu, yadia have. Del T, del V. Sigi uneasy money have meaning the siga money have. Well, this is equal to this having meaning the this is equal to this have. So that means del A by del T is del A by del T at constant volume. This is entropy. So negative entropy. So this is minus entropy. So minus this term inside the bracket is minus entropy. So minus del S by del V at constant temperature. So this expression, okay. So this expression is equal to this. This is equal to this expression. Sigi expression, Del A by del V di kayo, del A by del V at constant temperature di kayo, minus pressure. So this is minus del P by del T. Del T at constant volume. Minus minus se kang nag re kari lemo re del S by del V at constant temperature is equal to del P by del T at constant volume. Si phangeba. Sigi equation ji kari kawi Maxwell's equation. Maxwell's relation in thermodynamics. Maxwell's relation in thermodynamics and relation mari lay ko. Adigi manungda this is one of those relations. Yarba. Aduna sina haidi kaino magic kari kanai masina this allows us to calculate the entropy of a substance in terms of the pressure, volume, temperature dependence of the substance. This allows us to calculate the entropy of this substance. Entropy is directly measurable quantity na take off. This allows us to measure or calculate the entropy of a substance in terms of pressure, volume, temperature. Pressure, volume, temperature is interdependence to khang targadi substance to substance to state to entropy khang khotong ngamgreba. Adugi idea to niko. Okay. Next up, if we can see chain rule. The chain rule for partial derivatives. Partial derivatives की chain rule. Partial derivatives की chain rule है कदी. Suppose I accelerate chain rule का CHAIN chain rules for partial derivatives. Chain rule for partial derivative. Chain rules. Suppose this U is a function of X and Y. U is a function of X and Y. Adudagi amuk X ko Y kasi. X ko Y kasi amuk they are again functions of a variable T. Smile raba. U have a function of U is a function of X and Y. Adudagi amuk mangon toriba sige X ko Y kasi amuk they are again functions of another independent variable T. Targadi. What is the expression for du by dt? Du by dt je. Chain rule niga. This is nothing but partial derivative of u with respect to x multiplied by the derivative of x with respect to t. Plus the partial derivative of u with respect to y multiplied by the derivative of y with respect to t. This is the chain rule for partial derivatives. See, what kind of partial derivatives ki chain rule kawe. Yarba. So already we can consider one example. See, how you got chain rule is session naraga. Koi example ama solve to we See, I start on ge adu go noi lotion bari jum the lotion logo fa. Example. U have functions in a x square y plus xy square whatever. The key xt have a sina t times e to the power minus t whatever. Yt have a sina e to the power minus t whatever. You calculate du by dt. Du by dt kari tagat ge hai. Du by dt hot ke hargadi ai hoje kari pangre from this expression from the chain rule. If I want to calculate this du by dt, first you should calculate the partial derivatives with respect to x the partial derivatives with respect to y. So to calculate 60 digit du by dt is I never got. This is equal to del u by del x dx by dt plus del u by del y dy by dt. So let us first calculate del u by del x. U is u is this. So what is del u by del x? From this, you differentiate with respect to x, keeping y constant. So this is twice xy plus y square. Next, what is del u by del y? Del u by del y. This is the given function. So del u by del y is equal to x square. Y derivative 1 direct x square plus twice xy direct. So we have calculated del u by del x, del u by del y. Then again, let us calculate this del x, dx by dt, dx by dt, dx by dt. X is this. So product rule palani dx by dt. So this is first. First, you differentiate t. T differentiate toward e to the power minus t plus t t e to the power minus t is differentiate toward. So this will give us minus e to the power minus t. So this is nothing but I can take e to the power minus t common. E to the power minus t common so 1 minus t. This is dx by dt. Similarly, dy by dt. Dy by dt is equal to y this. So my derivative t minus e to the power minus t. So therefore du by dt will be equal to this multiplied by this del u by del x multiplied by dx by dt. So it will be 2xy plus y square multiplied by e to the power minus t 1 minus t. So plus del u by del y. Del u by del y is this x square plus twice xy multiplied by dy by dt. Dy by dt is this multiplied by minus e to the power minus t. When you simplify this, the final answer that you will get is 1 minus t minus 3t square e to the power minus 3t. So when you simplify this, you should get this answer. So the page number 254. That example. Okay. Okay, then we can look up the next topic. Okay. Then rules x ko y ga nataba. Suppose in this chain rule, I have considered u as a function of only two variables, x and y. X and y then nataba. Suppose f, this function f depends on more than two variables. X, y, z, and so on. X1, X2, X3, X4, X5, X6, and so on till Xn corresponding. So let us consider this case. Karamba case no have u is a function of many variables. Variables may have x1, x2, x3, x4, and so on till xn, n number of variables. U is a function of n number of variables. which are represented by x1, x2, and so on till xn. And then each of these variables, x1, x2, x3, and so on, if each of these variables, they are again functions of t. So xi, xit. So each of these variables, x1, x2, x3, they are functions of t for I from 1 to n. aduna use x1, x2, x3, xn, n number of variables ki function oiraba. adu haiba x1, x2, x3 mayam ji amuk t ki function oiraba. adu oiragadi in such a case, what is the value of du by dt? What is the value of du by dt? Right? This du by dt will be equal to del u by del x1 dx1 by dt plus del u by del x2 dx2 by dt and so on till del u by del xn dxn by dt. See how we enable. I got. See we enable. I got. So if there are n number of variables here, you will get n number of terms here. I'm already so I am going to sadurakaneva. Sigi krai seasoner kani akoina the vector analysis as you garukani ka say sigi use this u can be the position vector to give magnitude of vi. This u can be the magnitude of the position vector. The magnitude of position vector is dependent on the values of x, the values of y, and the values of z. Aduna sige use in a position vector ki magnitude already it depends upon x, y, and z. Three variables ki makha polakane. Aduna dr by dt holapo matamda ko swaina expression ahum phangane. Recall. Another special case among khaner. Another special case ta sina case amale recall. Another special case ta u is a function of two variables x and y is a function of x. Sorry, y is a function of x. I believe y is a function of x. Okay, u depends upon x and y. Y now is a function of x. Sure, how will you calculate du by dx? This is equivalent to this example. This is equivalent to this example where x ko t ga manarakanda hojiki special case to phangeba. Aduna sigi t je x ko manarakanda hojiki special case to phangeba ko. So f of x and y, where x and y both depend upon t do. So x t ju hai manaru matamda I say du by dx phangeba. Du by dx. Du by dx. If x is equal to t in this expression, this becomes du by dx, dx by dx. This will be 1. 1 over aduna koi first term this we will get as del u by dx. Okay, plus du by dy, du by dy. Next dy by dt, dy by t x dx. Instead of t we write x. Silicon. Aduna use it depends upon x and y depends upon x. So entirely du by dx is del u by del x plus del u by del y times dy by dx. Okay. Example. Here we have another example. So example is u is equal to y sine x. U is equal to y sine x, and y is equal to x e to the power minus x. X e to the power minus x. So u depends upon y and x, and y depends upon x. So it is the case of this C case. It is this case, an example of this case. You calculate du by dx. Du by dx, what we shall use this formula. Du by dx will be del u by del x plus del u by del y dy by dx. So let us calculate each of these terms. So first, this is u. So let us calculate del u by del x. Del u by del x, del x. What is u? U is this. U is this. So if I want to differentiate with respect to x, I will treat y as a constant. So this will be y cos x. Next term. Del u by del y. Del u by del y. U is this. So you treat x as a constant and then you differentiate with respect to y. So this will give you the simple answer, sine x. Next, next we have to calculate dy by dx. So let us calculate dy by dx. Dy by dx. It is this product of two functions. So first you differentiate this and keep the second function, plus you keep the first function and differentiate the second function. This you can take e to the power minus x common and take 1 minus x. Now you substitute these three values in this expression. This expression is the value of homework chapter. The final answer. Let me write down the final answer. You calculate it at your home. Du by dx. The final answer will be e to the power minus x sine x plus x e to the power minus x cos x minus sine x. So today I think I'll stop here. I'll stop the recording.